Chapter 7, Lesson 4, Properties of Similar Polygons. You will be able to identify similar polygons and find missing measures of similar polygons. If two polygons are similar, then their corresponding angles are congruent and the measures of their corresponding sides are proportional. Both things must apply in order for the two polygons to be similar. So they must both have congruent angles and their measures of their corresponding sides are proportional. So letter A. As we can see here, we have two rectangles. We have HJKL is similar, and MNPQ. We need to determine if they're similar and explain why or why not. Now, if we look at both rectangles, they all have right angles. So I know the angles are congruent. So the second criteria is that the sides are in proportion. So let's compare HJ to MN. Let's compare JK to NP, KL to PQ, and LH to QM. HJ is 7, and MN is 10, and that's reduced. JK is 3, NP is 6, reduce and get 1/2. KL is 7, PQ is 10, which is reduced. LH is 3, QM is 6, which reduces to 1/2. So as you can see here, the ratios of our corresponding sides are not congruent. Because of this, the rectangles are not similar. So let's write that in words. Rectangles are not similar because the ratios of the corresponding sides are not congruent. Determine whether triangle ABC is similar to triangle XYZ. Explain. Well, I'm not sure about the angles yet, so let's take a look at our sides. We will compare AB to XY, BC to YZ, and CA to ZX. And I'm figuring this out from here. Our two labels of our triangles. AB to XY, BC to YZ, and then CA to ZX. That's where these ratios are coming from. So let's compare them here. AB is 8, XY is 12. Reduce that and we get 2/3. BC is 6, YZ is 8. Reduce that and we get 3/4. CA is 6, ZX is 8. Reduce that and we get 3/4. So, because these ratios are not congruent, I know the triangles are not similar. So it doesn't matter if the angles are congruent or not, because I know just from the sides not being proportional, they are not congruent. So the triangles are not similar because the ratio of the corresponding sides are not congruent. Determine whether triangle ABC is similar to triangle DEF. Explain. So here, A and D are congruent, B and E are congruent, C and F are congruent. So I know the sides, or the angles are congruent. So now let's check out those sides. Again, to figure out what my ratios are, AB to DE. BC to EF. And CA to FD. Okay, so AB to DE is 4 to 6, which is 2/3. BC is 6, EF is 9, which reduces to 2/3. CA is 8, and FD is 12, which also reduces to 2/3. So here, our ratios are congruent, our angles are congruent, therefore the two triangles are similar. So the triangles are similar because the ratios of the corresponding sides are congruent and the corresponding angles are congruent. Scale factor is the ratio of the lengths of two corresponding sides of two similar polygons. You can use the scale factor of similar polygons to find missing measures. You can also find a proportion and figure it out that way, which is what we're going to do. So in this case, we are given that both quadrilaterals WXYZ and ABCD are similar. Describe the transformations that map WXYZ onto ABCD, then find the missing measure. So the transformations, it looks like we have definitely a dilation and a translation. So that's our first part. Now, we have some numbers on our sides again here. We're going to compare them and see if the sides are in proportion. So we have, I'm going to use these two sides, which are corresponding, and these two sides, which are corresponding. And I know that because if you look here, this 12 is in between this angle with 2 arcs and this angle with 3 arcs. And M is in between 2 and 3 arcs. 10 is in between 3 and 4 arcs, and 15 is also in between 3 and 4 arcs. So you can use just the visual aspects of this to figure out which sides are corresponding. Or you could look again here. BC is in the same position as XY, and CD is in the same position as YZ. We don't need to use 13 because I don't have anything with this side, so that number is irrelevant to this problem. Okay, so here's what we do. We're going to set up a proportion, and I'm going to start with ABCD. So let's compare 12 to our M on this triangle, and then 10 to 15. Here we have a proportion, and we know how to solve it. Let's cross multiply. 10 times M is 10M, and 12 times 15 is 180. Divide both sides by 10, and we get our missing length at 18. The two figures are similar. Describe the transformations that map triangle FGH onto triangle KLJ. Find the missing measures. So as we can see, our angles are congruent here. And that means because they're similar, our sides are in proportion. Our proportions will be FG and KL. So FG and KL are corresponding. GH and LJ, GH and LJ, and HF and JK. Okay, so what happened here is we had a rotation as well as a dilation. Now let's write out our proportions. We have an x and a y to find this time, so we're going to have two different proportions here. So our first proportion looks like reds have both numbers, so we'll go our bigger triangle to smaller. 6 to 3 equals, let's do black, 9 to y, cross multiply, 6y equals 27, divide by 6, y equals 4.5. And now our second proportion here. I'm still going to use the red 6 to 3 because, again, those are the two numbers I have. But this time let's do the blue, x to 6. Now notice how I used 6 first. I used FGH triangle first. That means I have to use FGH triangle here first as well. And I did this on this proportion as also. 6 was from FGH and 9 was also from FGH. Okay, let's continue. Let's cross multiply. 3x equals 36. Divide by 3, and x equals 12. Letter C. The two figures are similar. Describe the transformations that map one figure onto the other. Find the missing measure. So here we have to figure out which sides are corresponding. So I've got 1 arc and 2 arc, which is the 5. Over here, 1 arc and 2 arc, in between is a 4. Between the 2 arc and 3 arc on this triangle is x. Between the 2 arc and 3 arc here is 4.8. And then that means the last two sides are corresponding. So what happened here? Well, looks like a few things happened here. It looks like it definitely dilated. It also rotated, and it translated. So this one has 3. So again, they were rotation, translation, and dilation. So now let's write some proportions. I need to find x, so I definitely have to use the red. Other than that, you choose. Do you want to use the blue or the green? Doesn't matter. I'll choose the green. So let's compare this triangle to this triangle. So 5 over 4 equals x over 4.8. Cross multiply. 4x equals 24. Divide by 4. X equals 6. The two figures are similar. Describe the transformations that maps one figure onto the other. Find the missing measure. So between my 90 degree and my 1 arc angle is 21, and here 90 degree to 1 arc is 10.5. 90 degree to 2 arc is x. 90 degree to 2 arc is 10, which means then 29 and 14.5 go together. My x is in green, so I definitely have to use green, and then you decide what you want to use. I will use blue again. It doesn't matter. So our green, x over 10 equals 21 over 10.5. Cross multiply. 10.5x equals 210. Divide by 10.5. And x equals 20.